Okay. Yeah, lots of times I actually record you guys just so that when it comes to the end of the chapter, you can go back and listen to it again.
Yeah, I appreciate that.
Okay. So, geometric series. Okay, a series is an indicated sum of a geometric sequence. If the sequence has a first term g sub 1 and a constant ratio of r, the nth partial sum, and we're going to call that s little n, can be written as the sum of the terms or written in summation notation like this. Okay? In other words, we're taking g sub 1 plus g sub 2 all the way up to g sub n. But remember, we're talking about a geometric sequence, so they're being multiplied by some ratio for each one. Okay? Yep, a series is always when you're adding them together. A sequence is when there's just commas in between them. But the numbers are still the same, it's just one has a comma and one has addition. Okay? All right. So example of that would be like if I have 3, 6, 18, that is a geometric sequence. What's my R value here? Oh wait, I did that wrong. This should be 12. Okay? So my R value here is 2. But if it's a geometric series, it's going to be 3 plus 6 plus 12. Your R value is still the same, but you're adding. Okay?
So the first one's a sequence?
Yeah, because you have commas instead of addition. Okay? So this is a sequence. This is a series. All right. So, so this is like a general way that you would do this is you would write out all your numbers and add them up. But there's a much easier way of doing that. You can use this formula. S sub n equals g sub 1 times 1 minus r to the nth power over 1 minus r.
What was it? R to the
Nth power. Okay, so let's do an example. A geometric series is given by this. 4 plus 4 times 3 plus 4 times 3 to the second plus 4 times 3 to the third plus 4 times 3 to the fourth. So it asks us to write this in sigma notation. So this is how we do it. Sigma of I starting at 1. How many terms do we have? 5. If you count them, we got 1, 2, 3, 4, 5. So to the fifth power, to the fifth, to n equals 5, which is on the top. Our very first sequence, our very first number is what? 4. So this is our g sub 1, right there. Okay? So that'll be 4. What is our r value? 3. Yep, because it's multiplied by 3 each time, right? Times 3. Okay? And then it's going to be taken to the n minus 1 power.
Wait, this is. Oh.
Okay? So I'm writing it like this right here is written. That's part A. Part B, I'm going to write it with the other formula. So we have S sub 5, because there's 5 of them, equals, and we're going to put G sub 1, which once again is 4, times 1 minus 3 to the what power? 5th. Good. So,
Wait, why did you get 5? Oh, because R is.
yeah, n is 5. Okay? All over 1 minus 3. Okay, that's an R on the bottom. Okay? So if you calculate that out, first of all, you're going to have 4 times negative 242 over negative 2. And then that total will end up being 484. All right, so what I want you guys to do, I just gave you an example on 1A on how to do this. So guess what you get to do?
The rest of it.
You get to do 1B. Fractions the same way. Don't worry. So I want you guys to try to do it on your own. I'm going to show you in about 2 minutes, but I want you to try it on your own first, okay? Okay, so this is what I got for my sigma notation. I have I always starting at 1. And what is my n value? 6, because there's 6 of them, right? We have 1, 2, 3, 4, 5, 6. Okay? So, our very first G value is 6. And you know what? The easiest way to find out what your ratio is to take the second number divided by the first. So if you take 4 divided by 6, that's the same as 2/3. Okay? So you always take your second divided by first. That's your R value. Okay? So 2/3. Yep, to the n minus 1. We're just setting it up as sigma notation at first. Okay? All right, so the second part, you're going to say s to the sub 6, because there's 6 n's, right? And this is going to be 6 times 1 minus 2/3 to the 6th power, all over 1 minus 2/3. Yeah.
Could the 1 over 2/3, like, would you eliminate that?
No, you can't. Okay, so what I got for the top, and I want you guys just to double check my math because I got something different than some of you guys did. I have negative 5.4732.
I got that. What?
That's what I got for the top value.
What do?
And then on the bottom, I have 1/3.
Well, I got the same top.
Well, this is the same as saying 0.3333.
Yeah, that's what I got. That's exactly what I got.
Okay, and then I have 16.42 for my final number. Okay, why is the top negative? That's because when you take 2/3 to the 6th power, that's going to be bigger than 1.
That is not, mine was not negative.
I got point.
Oh, no, that's not bigger than 1, but it times, this will be negative, right?
No.
No.
Yes, it was.
Yeah, it'll be
It is
1
negative.
minus.
But then shouldn't
No,
it be
it'll
a
be
negative?
1 minus
No,
that.
because it's
So
1
both
minus.
negative.
No, it's not.
Okay, ladies and gentlemen, let's just do this real quickly, fast, okay? So, 2 to the 6th power is what?
It's 0.0877.
Minus 0.0877. That?
Yeah, and that gives you a negative because it's less than
1 minus
One.
0.0877.
It's not negative.
It's
That's not negative.
1 minus 1 minus.
Okay, I think what happened there is I just have, I had a negative there for some,
You swapped the 2. You did 0.877.
okay, that's what I did. So I did it right except for the negative. Okay. All right, so this should still be your final number. Okay?
I told them on that.
Let's go to the next page. Okay, so now this is already in sigma notation. So they're wanting us to use the other formula to find out our total, okay? So in this case, we're going to do S, and what's my n value again? 6, okay? And my G sub 1 is what? 24. 1 minus 1/3. Very good. Okay? And it's going to be to the what power? 6, right? To the nth power.
Well, wouldn't it be 5 of I minus 1?
No. No, this is how the other one was written too.
Why does that?
So go back. Why isn't it not n minus 1? Because all of these are like that. Okay? So notice that it's n minus 1 right here, but this is just to the n.
Oh.
Okay?
It's different. Okay.
Okay, so here we have 1 minus 1/3 on the bottom. All right? So if I go through and calculate this out, in decimal form, I'm going to have 35.95. If you were to actually do it without decimals and keeping it in fraction form, you should get 8,748 over 243. And the reason I'm saying this is because I noticed the book kept them all in decimal form. Not decimal form, in fraction form. Okay? For my personal preference, I don't care. If you want to put it in decimal form, that's just fine with me. But when you're checking over your work in the answer key, it might be in fraction form. So if it's in fraction form, put it in your calculator and see what the decimal equivalent of it is.
Well, we're not allowed to use calculators that have fractions on the.
So all you do is you take your top divided by your bottom. Okay? So if you don't have a calculator that has a fraction function, all you do is take the top divided by the bottom, and that'll give you the decimal form, okay? Okay, this one right here is a typo. It should say I minus 1 here. Okay? So, if I put this in S sub what? 10.
And then 3?
Okay, is that my very first one?
No.
What is it? It's going to be 1 because it's not even shown.
Because if it's times 0, it'd be nothing.
Yeah, so the G sub 1 is just 1.
Wait, what?
This really should, if you were to write this, you know how whenever you have just an X, what's really in front of it? 1. This doesn't have anything in front of it. This one does.
I know.
Okay.
How do we know that the 3 isn't actually in the place of the 24 instead of the 1?
Because this I value is attached to it.
So if it was in the place of the 24, it would look how?
It would be 3 times 1 to the I.
Right. If it were the other way around, it would be 3 times 1 to the I power. Okay. So 1 is our G sub 1. We have 1 minus 3 to the nth.
To the 10.
Oh, yes, you're right. Sorry. This should be 10.
Oh, no. 0.
Okay? And then we'd have
Oh, no.
1 minus 3. All right?
I dropped Spanish for a reason.
Okay.
I was Spanish once, so it made perfect sense to me.
That's the value I got. It's a big old number. 29,524. Any questions on that one? No, because the top part's going to be negative, and also the bottom part's going to be negative. So it'd be a negative divided by a negative. So, like, this is what I actually got for the top. I have negative 59048 divided by negative 2, so that becomes a positive.
So then would that be the fraction that would be in the book?
This one's not a fraction, it's a whole number. Okay, because it ends up being a whole number. Gunner. Okay, an alternative formula for the sum of geometric series can be found by multiplying the numerator and denominator of the formula for S of n by a negative 1. The alternative form avoids negative signs where r is greater than 1. So you can turn it around and make it look like this instead, just to force it to have a positive answer. Then you're not dealing with negatives for when r is greater than 1. This means the exact same thing. You'll have the same answer. So whichever one you want to use is fine by me. As the other one. It gives you the exact same answer. Yep. Okay. So moving on for number 3A. Recall the disease outbreak from lesson 8.4. This was at the very beginning of your notes yesterday. This time assume that the first week there are 14 cases and that each week thereafter of new infections increases by 25%. Use sigma notation to express the number of people infected by the nth week. Okay? So, here's my sigma. My I starts at what? 1, always a 1. What's my n value? It's just n. We don't know because we're going to the nth week. Okay? And what's my g sub 1? 14. And what is my percent? So it's going to be 1.25. Okay? Because it's going to be itself plus a quarter, 25%.
To the what?
To the n minus 1. Because whenever you're using a percent value of how much it's increasing, it's going to be the same as itself plus 25% more. So it's going to be at least its own value the next time. So it's going to be 14 plus 14 times 25% of itself. Okay? Yeah.
An easier way to think about it is like you just have to increase it, so it has to be at least 1.
Yes. If it's a decrease, it'd be less than 1. If it's an increase, it's going to be greater than 1.
Is that an n over the sigma?
Yes, that's an n. So, how many people have the disease by the end of the 5th week? Mm-hmm. 14 for g sub 1. And I'm going to use the new one that we start off with r to the nth, so I'll have 1.25.
So why are you doing this in sigma?
Whenever we're actually calculating out, we're going to use this, because otherwise, if I have to write out every single one, it's kind of a pain.
Why would you have to do that?
If I did this in sigma, it would be 14 plus whatever 14 times 1.25 is, plus that number times 1.25, plus that, it's a lot of calculating.
Oh, because it's 1.25 of the new.
Yeah. Okay? So we're going to use the formula because it saves a lot of time. So 1.25 to the nth power, which is 5, minus 1. That's 1.25, sorry. And then this is going to be 1.25 minus 1. If you calculate all this out, you're going to end up with 114.90. And notice, can you have a 0.9 of a person?
No, you can't.
So we're going to round it up to be 115.
I got it.
Okay?
I got 136.
Okay, so let's just double check our calculating here. In the previous sets of examples, the number of terms of the series was known, and you were asked to find the sum. In this example, we're going to reverse that, okay? You're given a sum, and you're trying to find one of the first terms, okay? So in this case, the maximum number of natural ancestors that you could have are 2 parents, 4 grandparents, 8 great-grandparents, and so on. Okay, assuming that no one appears twice in your ancestral tree, in the past n generations, you have s to the n natural ancestors. So does that make sense to you where they got that? Okay. How many generations must you go back before you have 1 million natural ancestors, assuming no one appears twice? So our s sub n value is going to be 1 million. Okay? We already know g sub 1. What was that? 2. And we know that it's changing with an r value of 2. And we're going to have that to the nth power minus 1 all over 2 minus 1. So what's 2 minus 1? 1. So basically the denominator drops out. Okay? So we are left, I can just write this out again as 1 million equals 2 times 2 to the nth minus 1. Okay, so I want to simplify this a little bit further. I can get rid of this first 2 by doing what? Dividing them both by 2. So I have 500,000 now equals 2 to the nth minus 1. Add 1 to both sides. Okay, so now you can either guess and check using your calculator, which takes forever, or you can use something that you learned in Algebra 2 or Advanced Algebra called logs. Okay, so all you need to do is just follow what I'm doing. It's not hard. You're going to take the log of 500,001 equal to the log of 2 to the nth power. Yeah, what happens to this little n here? Yeah, so this little n on the top with the rules of log, you got to know that that will move to the front of the log. Okay? So that's the same thing as saying n log 2.
So that's what you're gonna type in.
You're going to type in log of 500,000, 500,001 divided by log 2. And then that's your value. Oops. Oh, no. Okay.
Wait, so you got that one divided by.
Yeah, so log 500,001 divided by log 2. You should get a value of around 18.93. So, do you have 18.93 of a generation?
No, 19.
Yeah, you could round it up to 19. 19 generations. Okay?
So on a test, is it always gonna round up like that?
Yeah, you could round down if you're below 5.
No, but like,
So it's not
you can't
like-
have half a generation.
Yeah, for this though, it's so close to almost 19 that it's an estimate anyway.
So it's like just a rule of rounding.
Yeah.
It's not like, because some teach, like I remember with Miss Russell, it was like,
Always round down.
yeah, if you like have like half a person, you just don't count that.
Yeah. Well, you got to remember on ACTs and MCAs, you're gonna see one that's really close to your answer. Yeah. 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 Always use log base 10. All right. So 4B, you do it the same exact way. I'm going to challenge you guys to do that real quick by yourself right now. See if you can get the same answer I will, and I will post that in a minute. Okay, so my n value is about 7.97. And so because it's so close to 8, I'm just going to say it's 8 generations. All right? So hopefully that will get you to what you need to do for your homework for Thursday. Now, Thursday you will have a warm-up on this and yesterday's assignment because I didn't get to it today. All right?